episode is sponsored by The Ridge. Go to ridge.com/SciShow to see their holiday guide and use promo code SciShow to get 10% off your next order. When you think about what makes a planet habitable, you might come up with liquid water on the surface, an oxygen-rich atmosphere, and maybe what type of star it's orbiting. One thing that probably doesn't make your list is the planet's radioactivity. But according to a new study, the abundance of radioactive elements inside a planet could indicate whether it can support life. And not in the way you might think. Because while we usually think of radioactivity as a bad thing, planets like ours might not be habitable without it. This paper was published last week in the astrophysical journal Letters, and it focused on two long-lasting radioactive elements, uranium and thorium. Elements like these are made in rare events like neutron star collisions and possibly certain supernovas. So depending on where a solar system forms, a star and its planets can be made of different amounts of them. And according to this team, the amount of uranium and thorium a planet starts with can make all the difference when it comes to habitability. They base their model on Earth, and Earth's interior has two main heat sources. One is the energy generated by all that metal and rock squishing itself into a giant sphere when the planet formed, and the other is radioactive decay. This is when unstable atoms break down and give off radiation and ultimately heat. But it's not actually how hot a planet is that's important here. It's the change in temperature as you move from the core up through the crust. For an Earth-like planet, you want a core that's hot enough relative to the mantle to drive the motion of a liquid metal dynamo, basically a planet-sized lava lamp. Broadly speaking, this is when metal in the outer core gets warmer, becomes less dense, and floats up. Then it gets cooler and denser, sinks down, and the cycle repeats. On Earth, this dynamo is extremely important because it creates our strong protective magnetic field. This field directly protects life from harmful space particles, and it stops the atmosphere from being stripped away by radiation from space. So according to this paper, how much heat radioactive elements generate could be a big deal. Using computer simulations, they demonstrated that if Earth formed with more uranium and thorium, a lot of it would have been trapped in the mantle and acted as an insulator. That would have made the temperature of the mantle too similar to the core for the churning dynamo to keep going, so we would have lost our magnetic field. On the flip side, the simulations also confirmed that if Earth had too little radioactive material, it would cool too fast and become geologically dead, with none of the processes that lead to volcanism. And volcanic activity was important for creating Earth's early atmosphere. So for Earth to work, everything had to be just right. That said, these are only initial predictions using a simplified model, so before we can say this is definitely a thing, we'll need more simulations. But if we can get to that point, astronomers could use this information to keep hunting for habitable planets, looking for signs of uranium and thorium in other worlds. Meanwhile, in the journal Science, researchers published another paper last week about a world closer to home, Mars. And this time, they're challenging some ideas about how Mars is losing its water. Thanks to decades of exploration, we know that the Martian surface used to be covered in liquid water. We also know that what water is left is vanishing before our eyes. The classic idea is that this happens in a slow, steady trickle. Exposed water ice on Mars turns into gas, which accumulates in the lower part of the atmosphere. Then those water molecules occasionally get struck by energetic particles from space, which breaks them into lighter compounds, which then float up and away. Except that's not what this team found support for. In this paper, they looked at the abundance of gases in Mars's upper atmosphere using data collected by the MAVEN spacecraft. And among other things, they found that there was a lot more water in the upper atmosphere than predicted. They also confirmed some older results about how Mars's water loss changes with the seasons, something that doesn't match the classic idea about that slow, constant trickle. According to them, all this helps explain how Mars really loses its water. Instead of gathering in the lower atmosphere, their evidence suggests that the water vapor rises high above the surface into the ionosphere. There, it lasts as briefly as a few hours before it's destroyed by reacting with charged carbon dioxide molecules. That's over 10 times faster than what we previously thought. The team also proposed that this process would change with the seasons, with more water vapor moving to the upper atmosphere as Mars approached the sun. And finally, they confirmed just how important the planet's dust storms are to water loss. They're not clear on how it happens, but they found that a global dust storm can transport as much water into the upper atmosphere as what might normally happen in a whole year. Overall, this kind of information is great for understanding what's happening on Mars today, but the researchers use it to look to the past, too. From the MAVEN data, they extrapolated back 1 billion years, and they estimated that thanks to both of these processes, Mars would have lost hundreds of trillions of liters of water since then, the equivalent of a global ocean 61 centimeters deep, or a global puddle. a really deep puddle. So there's still a lot of research to be done in piecing together Mars's history and in understanding what it takes to have a planet that can support life. But thanks to studies like these, we're getting closer and closer every week. If you're working on your holiday shopping, you might be interested in this week's sponsor, the Ridge. The Ridge wallet is light, sleek, and is intended to be something you use every day. It holds up to 12 cards plus cash, but also won't bulge in your back pocket. If you want to give one as a gift, the wallet comes in more than 30 colors and styles, and if you want to test one for yourself, the Ridge team can hook you up there too. They'll let you test a wallet for 45 days, and if you don't love it, you can send it back for a full refund. To get 10% off and free worldwide shipping, you can go to ridge.com/SciShow and use the code SciShow.